Now we're looking at problems involving the quotient rule and the product rule if we're dealing with the numerators and denominators separately, involving variables. So with part A, we're given the square root of a to the 8th over a to the 6th. There are a couple different routes we can take here. We can simplify under the radical first, or we can separate it into two separate radicals, one in the numerator, one in the denominator, and then simplify. We're going to keep it in the simplest form and simplify under the radical first. So the square root of a to the 8th over a to the 6th, well, a to the 8th over a to the 6th, that's a to the 8th minus 6, which is the square root of a squared. Now again, we're taking the square root of an even power, so we have to worry about our absolute value. When we take the square root, we're left with a, the absolute value, so the square root of a squared is the absolute value of a. Part B will solve in a similar fashion, only we're dealing with the cube root. So the cube root of x to the 7th over x cubed, that equals the cube root x to the 7th over x cubed is x to the 7 minus 3, which is x to the 4th. Now we'll break that up into perfect cubes, or any factors that are perfect cubes, and what's left. So we're left with the cube root of x cubed times x. No absolute value needed because we're dealing with the cube root. Cube root of x cubed is simply x, and we're left with the cube root of x. This last one we'll do it both ways. We'll first simplify underneath the radical, so the 4th root of 17 minus 5 is 12, so this is y to the 12th. That equals 4th root of y cubed to the 4th, and it's an odd power. We're taking the 4th root of something to the 4th, so that something with the odd power needs to have its absolute value, so this would be the absolute value of y cubed. And for purposes of this course, we're done with the solution. Some would say you could simplify this further to y squared times the absolute value of y, since we know that y squared is positive. Now let's do it the other way, and we'll separate it into the 4th root of y to the 17th over the 4th root of y to the 5th. That equals the 4th root of y to the 16th times y over the 4th root of y to the 4th times y. And when we separate these, we end up with the 4th root of y to the 16th is y to the 4th. We're left with the 4th root of y. 4th root of y to the 4th. We have the absolute value of y, and that leaves us with the 4th root of y. That equals y to the 4th over the absolute value of y, and when we simplify that, we end up with the absolute value of y cubed. So again, the 4th root of y to the 17th over y to the 5th simplified is going to be absolute value of y